So what we're going to go over now is how we use vector component addition to essentially calculate the vector sum of some vector quantities, right? The most important part of that is something that we just did, right? And that is resolve a vector into its components. And we did that just a minute ago with the question about the person walking from their tent to the lake, right? We had that overall displacement that looked like this, okay? We knew that in that overall displacement, they had gone 1.2 kilometers east and they had gone half a kilometer south, okay? We had just resolved this vector into its x, 1.2 kilometers east, and y, 0.5 kilometers south, into its two components, right? We always have to do that, and we can if we're given the magnitude and direction of a vector quantity, right? Because we can always make a right-angled triangle out of it if we know those two sides, okay? Or at least if we're given enough information to calculate those two sides. Everybody follow me on that, right? So that's what we're going to have to do, and then when we have a number of vectors, we'll be able to figure out how far east or west it went in total, how far north or south it went in total, and figure it all out. Okay? Now, right now, that may seem a little bit daunting, and the first few times you do it, it's going to take you a long time. But trust me, you'll get faster at it, because it's basically the same steps for every single question. Once you figure out the steps, you just have to get faster at doing them. Okay? All right, so here's what we're going to do. We are going to do an example before I even teach you how to do it. Because the best way to teach you how to do it is show you one first. And then when I'm explaining it, you'll have a visual memory of, oh yeah, that's what that looked like. So that's what we're going to do first. So I want you to copy this down, and then copy and follow me as I go through. And I'm just going to walk you through the whole thing. So we're looking for the total displacement of a boat that travels 8 kilometers at 30 degrees south of west, and then 3.5 kilometers at 50 degrees north of west. Okay, so I write that down, and then we'll start it. Okay, so the first step in any vector addition question is to draw the vector diagram. Now, looking at this question, do I go west a lot in this question? Okay, so I want to make sure I leave myself enough room going from right to left on the screen here to finish the diagram. So I'm going to start over here, okay, and I'm going to go south of west. So here's my starting point. I'm going to draw myself a reference line that is due west. And then I'm going to go south of that 30 degrees. Okay, so 30 degrees would be about this much. All right, so that's going to make a triangle that looks like this. 30 degrees in here. Here's the x, or horizontal component of that. It's going west. Here's the y, or south component of that. Okay? And this side here is 8.0 kilometers. It then says that after that, it goes 3.5 kilometers at 50 degrees north of west. So again, since my angle is measured from west, I'm going to draw a line that's west. Okay? And I'm going to go 50 degrees north of that. So maybe something like that. All right? That's about half as long, maybe a little less than half as long as this line. So I'm retaining my scale fairly well. This is 50 degrees. This is 3.5 kilometers. And this would be my north, or y component. And this would be my west, or x component. Okay, so I always put arrows on those just so I remember which way they're going. Okay. Honestly, guys, this is the hardest part of the question. Yes, there's a lot of math and a lot of trig after this, but it's always the same. Getting the picture drawn is the hardest part. If you don't get the picture drawn right, even if you do all the math right, you won't get the right answer because you won't be doing the right math. Okay? You'll get all the math right for what you drew, but you didn't draw it right, so it won't end up with the right answer. So drawing the picture is the most important part. Okay, where would I draw a line that would represent the total displacement of this boat?
From the starting point to where 3.5 kilometers ends.
Yeah, exactly. From the beginning of my black arrow, here, the starting point, to the end of my red arrow. Because I did this first, the black line, and then I did the red line. So this is going to represent my total displacement. I go somewhat south and a lot west. Everybody okay with that? Okay, so right now I've got a lot of x's and y's on here. I've got a lot of thetas on here too, okay? And that's all right. But that's basically a vector diagram for this question. Okay? Now, if I'm going to figure out how long D is and what direction D goes, I need to know blue x and blue y. Agreed? Because if I knew those two sides, I could use Pythagorean theorem and trig to figure out how long blue D was. All right. If I look at this diagram, if I take black x, okay, this line here, and add it to red x, will that give me blue x? Yes, that's vector component addition. I'm taking the x components and adding them together to get my total horizontal displacement. If I take black y, okay, which is this one here and is south, and I take red y, this one here, which is north, and add them together, will I get blue y? Yes, I will, because one's negative and one's positive. Okay, that's adding the two vertical components together to get the total y. Okay, so that's what we have to do. Is we got to. So, and you're probably looking at that right now, going, "Well, that's all well and good, Coder. You don't know what those numbers are either. You got x and y written there too." Yes, I do, but I know the hypotenuse of each of those other triangles and an angle. Can I figure out all the sides if I know one side and an angle? Mm-hmm. That's where the trig comes in. Okay, this is how I'm going to use trig to find all the components. Okay, we said you have to resolve a vector into its components. You resolve it into its components by using trig. All right, so we're going to walk through that process now. Okay, this is stuff you've done. Okay? You've done sine, cosine, tan calculations before, so it's going to seem like a lot all at once, but it's all stuff you've done before. Okay? So if I want to find black x, okay, black x is right here. It is adjacent to the 30-degree angle. And I have the hypotenuse. What trig function relates the hypotenuse and the adjacent side? Cos. Right. So if I want to find x, okay, x is going to be cos of theta equals the adjacent side, which is x, the one I'm looking for, divided by the hypotenuse. So if I want to find the adjacent side, x, what do I do with hypotenuse? Right, I multiply it over to the other side. Okay? So x will be the cos of theta, which is 30 degrees, times the hypotenuse, 8. Right, so all I'm doing is manipulating, okay, that simple trig ratio. All right, so if I punch that into my calculator, making sure I'm in degree mode, okay, the cos of 30 times 8 is 6.928. Okay, I need to keep all my decimals when I'm doing this. Okay, that's another thing with significant figures. Keep all of your decimals all the way along until the very end. If you round anything off in the middle, you're going to affect your accuracy at the end. Okay, so I'm just going to write 6.928, but I'll keep all the stuff in my calculator. Okay, kilometers, and that's west. Sometimes I even write that on the diagram just so I have it there. Okay, now I want to find black y. So, what side is it in relation to this angle? Opposite. Okay, so I have the hypotenuse, the angle, and I'm looking for the opposite side. Which trig function is that? Sine, right. Okay, so I'm going to go sine of 30 times 8, and that's going to be 4. Impressed? I did trig in my head. Don't be impressed. The sine of 30 is 0.5. It's That's why I always pick 30 as an angle, because then I can do one of the calculations and feel good about myself. All right, so we got 4 kilometers south. Okay, that's what this y here is. So in that first vector, I go 4 kilometers south and 6.928 kilometers north. Or sorry, west. All right, so I've got those two. Now I need to do the same thing for the red triangle. All right, so I just got different information, but I'm going to do the same calculations to calculate x and y for the red triangle. Okay, so if I want to find red x, it just happens to also be adjacent to my 50-degree angle. So which trig function will I use? Cos. So I'll go cos of 50 degrees times 3.5 this time. All right, so we got 2.250. That's what I'll write, but I'm going to keep all the decimals. And that is west. Okay? And then I want to do the same thing for y, except that y is opposite this angle. So I'm going to use what trig function here? Sine. Okay, so that side's 2.681. I'll keep all those decimals like I say. All right, so now I've found all the x's and all the y's. In other words, I've resolved all of my vectors into their, starts with C, components. Okay, I found all the x and y components, or all the horizontal and vertical components or parts of the trig. Okay. Now, all the x's are collinear. I can just do what with them? Add them together. Same with the y's. Okay, they're collinear. I can just add them together. Okay. So that's what I'm going to do. We said if I'm going to find d, I need to know what blue x and blue y are. Well, blue x is going to be, okay, black x plus red x. Okay? We just said that if I take red x and add it to, put it on the end of black x, it'll equal blue x, right? That's how far west this thing went in total. Okay? Can everyone kind of visualize that? Okay. Maybe I can do this. Right? So there's red x. I just pulled it up and brought it over there. It's exactly a fit for that. Okay? See what I'm doing there? Right, so if I add those two together, that will give me blue x. So that's what I'm going to do. I'm going to take black x, which was 6.928, and I'm going to add it to red x, which was 2.681. Except I'm going to use all the decimals. I'm not going to round anything off here. So I'm going to have 6.928, 20323 plus 2.249, 756,634. Okay, so my overall west component, or x component, is 9.178. Again, I'll keep all my decimals. Okay, so over the whole trip, the boat went 9.178 kilometers west. Can I figure out how far south it went? Yes, I can. Okay, because if I take this one, and if I take red y, which is what I've got in my hand here, okay, and put it on top of black y, I get blue y. Okay, I get what's left there. Okay, so I'm going to take black y, which was 4 kilometers south. I'll make that negative. And I'm going to add that to my north, which was positive 2.681. Okay, that'll tell me what blue y is. All right, we'll pick up there, start a class tomorrow.
Blue X, you added the X and the Y.
Did I?
No, he still, that was the same answer though.
Oh, yeah, you're right. Oh, but I did in the calculator, I wrote this, but in the calculator I went 2.49. Yeah, it's 2.49, yeah, you're right.
Not a lot.
Yeah.